Okay, the last way to solve a quadratic equation that we're going to look at today is called completing the square. And in completing the square, what you want to do is first start off by dividing every term by a so that you get a monic polynomial. So it'll be like something like x squared plus b over a, x plus c over a. Then you move the constant to the other side and you add the quantity b over 2 squared to both sides. Then you factor the left side as a perfect square trinomial, and then you continue with square root property, so like we just learned. And this is obviously complicated, and so I'm going to say use this whenever you are told to. So that's kind of sad, but you won't have to use it very often. But we'll do 2 examples just so you see how to do it, and then after that I'll show you the easiest way to solve quadratics. Okay, so in part A, the coefficient of x squared, a, is already 1, so we don't need to divide anything. And then you note that b is equal to 4, so b over 2 squared is equal to 4 over 2 squared, which is itself 2 squared, which is equal to 4. Okay, so now remember that this says you need to move the constant over to the other side, so we're going to start with x squared plus 4x is equal to 1, so you're adding 1 to both sides there. And now you're going to add 4 to both sides. That's this part right here. So you add 4 here, and you add 4 there. And so you're left with now x squared plus 4x plus 4 is equal to 5. Okay, and it may not seem like this is any simpler, but if you notice that what I'm underlining in purple, that's actually equal to x plus 2 quantity squared. So when you added b over 2 squared to both sides, you made the thing on the left a perfect square. Okay, and also notice that the 2 there is b over 2. So it's always going to be the case that this is going to be x plus b over 2 squared. And now you can use the square root property. So you'll get that x plus 2 is equal to plus or minus the square root of 5. And so then x is equal to negative 2 plus or minus the square root of 5. Okay, so that's the first example. In part B, we're going to have to divide everything by 2, because you need to have this as a monic polynomial. It needs to be x squared plus bx plus c. So when you divide by 2 everywhere, you're going to get x squared plus 3 halves x minus 2 is equal to 0. And now remember that we need to look at whatever b is, which is 3 halves. You need to take b over 2 squared, which is going to be 3 halves divided by 2, which is the same as multiplying by a half squared, right? So 3 halves divided by 2 is the same as 3 halves times 1 half, which is 3/4 squared, which is 9/16. And so what you're told to do in this process is to move the constant over to the other side by adding it, adding negative 2, or adding 2 to both sides. And now we're going to add 9/16 to both sides to make the left-hand side a perfect square. And again, this may not look that simple, but what this is saying is that this green, what I've underlined in green, is now a perfect square. It's x plus 3/4 squared. And the right-hand side is, well, 2 can be written as 32 over 16. So the right-hand side is 32 over 16 plus 9/16. So that's going to be 41 over 16. So I have x plus 3/4 squared is equal to 41 over 16. And now you're going to take the square root of both sides, and we'll get that x plus 3/4 equals plus or minus the square root of 41 over 16. And so the final answer will be x is equal to 3/4 or negative 3/4 plus or minus the square root of 41 over 16.